Hello everyone, welcome to today's video. So in this video I've come with a very exciting problem. So this is one of the toughest and challenge problem that I've ever faced. I had to struggle a lot to find a perfect logic to solve this question. So it's a really fantastic question, and math geeks sitting out there will definitely enjoy this problem. So getting into the problem, this topic is of equations. Fine. uh, this is the question. So these are the conditions given to us. If a plus b plus c is equal to 4, so a, b, c are the three numbers, so they belong to R, and a plus b plus c is equal to 4, this is the first condition, and a square plus b square plus c square plus 3 of ab plus bc plus ca is equal to 21, and this is the second condition. So then we need to find the minimum and maximum values of a plus b into b plus c into c plus a. So it is like conditions are limited to only one variable, taking one variable at once, but here we have two variables and multiplying them. So it's a somewhat a tough question, because we don't get an instant logic. So how do we approach the problem? So basically we must use the conditions that are given to us. That's the only way that we can look out for. So first of all, writing the conditions that is given. So a plus b plus c is equal to 4, I will be using it at the last. Basically first I will be using the condition given, second condition that is given to us, that is a square plus b square plus c square plus 3 of ab plus bc plus ca is equal to 21. So this is the first condition that is given to us. So what I will be doing is, I will just expand this, okay, so that I can find some relation between a square, b square, c square and ab, bc, ca, and how could I relate that to the question that is given to us, that is a plus b into b plus c into c plus a. So somewhere or the around we can find a relation between these two. So I shall expand this, because that's the only way that I can proceed further. So a square plus b square plus c square plus 3ab plus 3bc plus 3ca is equal to 21. Fine. And now what I will be doing is 3ab, so that means ab plus ab plus ab, 3bc, that means bc plus bc plus bc, 3ca, ca plus ca plus ca. So all the three are actually coming in the equation for thrice. So I shall write them in an order. So a square, and I will be writing ab here. Like I will just write in a perfect way, a square plus ab plus bc plus ca. So one time is over, plus b square plus ab plus bc plus ca. I'll write in the perfect way, yeah, bc plus ca. Fine. And this is plus c square plus ab plus bc plus ca. Fine. So everything like ab, bc, ca are repeating for thrice, that is 3ab, 3bc, 3ca. I just written it in this way. So why did I write in this way? Because I found a relation between these three, like these three, relation between these three, these four, relation between these four, and relation between these four, and relation between these four. So what's the relation that I've got is this: a square plus ab plus bc plus ca is basically a plus b into a plus c. So a into a square, a into c, ac, a into b into a, ab, b into c, bc. So this is what I've got relation. So basically how did I get through it is, so a square plus ab is basically a of a plus b. So this one, a square plus ab, or you can you could even take it in this way, a square plus ca. A square plus ca is a of a plus c, and ab plus bc is, you can just take b common, a plus c. So now you have got a plus c into a plus b. So because the question dealing like the question in which in what we are dealing is, they asked us to find the minimum and maximum value of a plus b into b plus c into c plus a, and that's what we are finding, right? So some or the other way we are getting the components of the question in our part. So that's the reason I have proceeded in this way, like a plus c into a plus b is what we have got from here. So in the same way I shall erase this stuff. Yeah, in the same way here the relation that we gonna get is a plus b into b plus c. The same way you can just take b square and bc to be common, and at one component like b of b plus c you will get, and ab plus ca, again if you take a common you will get b plus c, so you can just take this common. In the same way this one you will get, we will get this to be a plus c into c plus b. So the component where we have square term, like here we have c square, so c will be repeating for twice. Here we have b square, so b will be repeating for twice, and the other two will be in this position. And a square here repeating for twice, so a and the other two will be repeating in the extreme position like b and c. So in this way we could come to the logic. So what's the relation that we have got finally? That is, yeah. So finally we have come to the relation that a plus b into b plus c plus a plus b into b plus c plus a plus c into a plus b plus, so b we have repeated for twice, c a we repeated for twice. Now the only thing that is left is c is left, so b plus c into c plus a. So this is equal to 21. So this is the relation that we have come to, like conclusion. And what's the second condition that we are given with? So second condition that we are given with is a plus b plus c is equal to 4. And this, if I multiply by 2 on both sides, I would get 2 of a plus b plus c is equal to 8, and twice of a plus b plus c I can write this as a plus b plus c plus c plus a. Fine. A is repeating for twice, b is repeating for twice, c is repeating for twice, and this is equal to a. So I've got the components that are in the question in my solution. So here we have a plus b into b plus c plus a plus c into a plus b plus a b plus c into c plus a is equal to 21, and here we have the individual component sum as 8. Here we have got taking twice and then adding them up, we are getting a value. So if I consider, now it is an important logic that we want to apply. If I consider my a plus b as some x1 and b plus c as some x2 and c plus a is equal to x3 as some as like this is the conclusion, like assumption that if I am taking, then I could say these are the roots of like x1, x2, x3 are roots of a cubic equation x cube minus 8x square plus 21x plus some lambda is equal to 0. So how did I come to this conclusion? Because if I assume that a plus b, b plus c, c plus a are three individual roots of this cubic equation, then the sum of all the three roots is 8. So that's the reason my coefficient of x square would be minus 8, and taking twice at once and then adding them up, we will get 21. So that's the reason my coefficient of x is 21. And the final lambda, what is lambda? Lambda is basically multiplying all of them, like the product of all the roots, that is a plus b into b plus c into c plus a. So this is what we don't know, right? So that's the reason I have assumed this as lambda and this is as my cubic equation. So if I assume this as x1, this as x2, this as x3, then I can come to a conclusion that x1, x2, x3 are the roots of this cubic equation x cube minus 8x square plus 21x plus lambda is equal to 0. So fine. So what's the next step that we can proceed? So we need to find the minimum and maximum value of lambda. So how do we do that? Is basically if I assume this f of x to be x cube minus 8x square plus 21x plus lambda is equal to 0 is my f of x. Now if to find the minimum value of lambda, so first of all what do we do is, so we need to eliminate x, right? So we need to eliminate x. So for that purpose we can just put some constant, some variable of x, like some value for x. Like if I put x is equal to 1, I'll be having no x here, I'll be just left with lambda. So what are the ways that we can come to so that I can just eliminate x and have only lambda, so that I can solve for lambda? So that there is only one way, and the known way to us, that's a hidden way actually, that's hidden in between this equation. That is, if I find my roots of, is equal to 0. Okay, uh, yeah, if f dash of x is equal to 0, like f dash of x is equal to 0 is a quadratic equation, isn't it? Because this is a cubic and this is quadratic, then I can say, and if the roots of this equation are alpha and beta, okay, f dash of x is equal to 0 as the roots alpha and beta, then I can say f of alpha into f of beta is less than or equal to 0, isn't it? Because this is f dash of x is equal to 0 is a quadratic equation, and that we have roots to be alpha and beta, and at this position of alpha and beta we have either the local maxima or local minima. So definitely the product of these two will be less than or equal to 0. So like it may be a double root of this cubic equation, that's the reason it may be equal to 0, but if that's not the case, we'll have these two to be less than 0, because alpha and beta at one position it will have local maxima, and at position another position we have local minima. So definitely one will be above the x-axis and the will be the below x-axis. So the product of these two will be definitely less than 0 or equal to 0 if one of the root is a double root of the cubic equation. So using that, so what will be my of alpha and beta? So my f dash of x is 2x square minus, sorry, f dash of x is 3x square minus 16x plus 21 is equal to 0. Fine. And if I just need to solve this, I can just put x is equal to 16 plus or minus b square, that is 256, minus 4ac, that is 4 into 3 12, and 21 12s it's 252. So divided by 2 into 3, that is 6. So x is equal to 16 plus or minus, this we are getting up to be 4, so we will get 16 plus 2 divided by 6 plus or minus 2 divided by 6, that is 16 plus 2, that is 18 divided by 6. Then we can get the like 18 divided by 6, and the other one is 14 divided by 6. So it is 3 or 7 divided by 3. Fine. So 2 7s 2 3s. So this is these are the roots of this equation, that's f dash of x. Now we'll just substitute this. So as told, if I assume my alpha to be 3 and beta to be 7 by 3, I could say f of alpha into f of beta is less than or equal to 0. So what is f of alpha? F of 3. So what is f of 3? You can just put in the cubic equation, that is 3 cube, that is 27, minus 8x square, that is minus 8 into 9, that is minus 72, and plus 21 into 3, that is 63, and then plus lambda is equal to 0. So I would get fine, we should not put that to be 0, we just need to find the f of 3 value. So 63 plus 27, that is 90, so 90 minus 72, that is 18, so we get 18 plus lambda. And at the same case, if I solve for f of 7 by 3, I would get that value to be 7 by 3 whole cube, that is 343 by 27, and minus 8x square, that is minus 8 of 49 by 9, and plus 21 of 7 by 3. So I could just write 49 here, plus lambda. So I would get 343. So it's better we take the LCM to be 27. So we get 343 here, and 9 3s, so 3 into 8, I would say 3 into 49, it's better. So 3 into 49, 147, and 147 into 8, so 147 into 8, and plus 3 of 9, 9 into 7, 63, so 63 into 21, plus plus I'll just write this here the separately, that is 27 lambda, or I would write it in a here I'll just write this component here, 27 lambda plus 343 divided by 27. So this is f of 7 by 3. So we can just put now, like I'll just write the final equation. If I just put the final equation, so I need to write f of 3 into f of 7 by 3 as less than or equal to 0. So if I solve this after multiplying them, I would get this value to be 18 less than or equal to lambda less than or equal to 490 by 27. So this is what I'll finally get this. So this is my minimum value and this is my maximum value. So if I'll just put those and just multiply them and equate, like put this inequality less than or equal to 0, this is the conclusion that I'm going to get. That I'm skipping this so that I cannot, like I can limit my video up to 16 minutes. I just don't want to prolong this. So this is how we will solve this. So the minimum value is 18 and maximum value is 490 by 27. So I hope you guys understood this. It's a very fantastic problem. So the main basic thing is using the set of equations that are given to us in a perfect way, and to find the hidden values, like hidden rules basically, because f of x is equal to x cube minus 8x square plus 21x plus lambda is what we have got to know, but we have no idea after what will be the steps after that. So I hope you guys understood this. Thank you for watching. Stay tuned.